Welcome. Today, we are diving deep into a field that is, quite literally, changing our world from the atoms up. We're talking about the fundamentals of nanotechnology. This isn't science fiction, it's happening right now. So let's jump in. You know, I want to start with a question for you. What if the next huge industrial revolution, the thing that's going to redefine everything, what if it was completely invisible? Well, guess what? It is. And that brings us right here. Welcome to the nanoscale. First things first, we've got to get a handle on this invisible territory and just how unbelievably small we are talking about. So what is it really? Well, the textbook definition is right here. Nanotechnology is all about controlling matter at the scale of atoms and molecules. We're talking between 1 and 100 nanometers. But here's the key. This isn't just about making things smaller. It's about building entirely new things from the ground up, literally atom by atom. Okay, for some perspective, look at this number, 80,000 nanometers. You know what that is? That's about how wide a single strand of your hair is. So the nanoscale we're focused on is hundreds, even thousands of times smaller than that. And if that didn't do it, try this analogy on for size. Imagine a single marble. Now imagine the entire planet Earth. The difference in size between that marble and the Earth, that's the same difference in size between a single nanometer and a meter stick. Yeah, it's a mind-bogglingly tiny scale. Now, this whole idea didn't just pop up overnight. It really started back in 1959 with the brilliant physicist Richard Feynman, who basically said, hey, there's this whole world at the atomic level we could build in. Then, in the 70s, Norio Taniguchi actually gave it a name, nanotechnology. But the real game changer was in 1981 with the invention of the scanning tunneling microscope. For the very first time, we could actually see and move individual atoms. That's when theory exploded into reality. Which brings us to the real aha moment of this whole field. Because the big question is, why is this so revolutionary? Why is being this small so different? And here is the absolute heart of it. When you shrink materials down to the nanoscale, they don't just become tiny versions of themselves. No, their fundamental properties can completely flip upside down. This happens for two big reasons. First, their surface area just explodes compared to their volume. And second, the weird and wonderful rules of quantum mechanics take over. Suddenly, things we thought we knew, like color, conductivity, strength, they all start to behave in totally new ways. Let's take gold as a perfect example. In our world, a gold ring, a gold bar, it's stable, it's non-reactive, it basically just sits there. But if you shrink that same gold down to nanoparticles, it becomes an incredibly powerful catalyst, something that actively speeds up chemical reactions. Same exact element, completely different personality. So why does that happen? It's all about that surface area. Think about a sugar cube. When you drop it in your coffee, only the atoms on the outside can touch the water. But what if you crush it into a fine powder? You've exposed way more of the atoms to the surface, and it dissolves almost instantly. The nanoscale is just that idea taken to its most extreme conclusion, making these materials hyper-reactive. And this all comes back to what Feynman was talking about all those years ago. He realized that the atomic world wasn't a dead end. It was a vast, open frontier for engineering. There really is plenty of room at the bottom to build amazing new things. Okay, so now we get what it is and why it's such a big deal. But how in the world do you actually build things with atoms? Well, it turns out there are two main strategies. You can either go top-down or bottom-up. The top-down way is kind of like a sculptor. You start with a big block of marble and you just chip away everything that isn't the statue. The bottom-up approach is the total opposite. It's more like a builder on an assembly line, carefully putting a cart together piece by piece, or in this case, atom by atom. Photolithography is the king of top-down methods. In fact, it's the engine that powers our entire digital world. It's basically a super advanced stenciling process. Engineers take a silicon wafer, they coat it, they shine light through a pattern, and then they etch away the material. They do this over and over, carving billions of microscopic transistors onto the tiny computer chips that run our lives. Now, bottom-up methods, these can feel a lot more elegant, almost like magic. Sometimes we can get molecules to just organize themselves into perfect structures. It's called self-assembly, and it's how nature builds things like snowflakes. Or we can use chemical vapors to deposit materials one perfect atomic layer at a time. And get this, we can even use DNA like programmable Lego bricks to build complex little machines. So when you look at this chart, you start to see the big trade-off. Top-down methods, like the ones used for computer chips, are fantastic for making tons of stuff really fast. They scale up beautifully. But bottom-up methods give you that exquisite atomic-level control. The future really is probably going to be a clever mix of both worlds. So we've covered the what and the how. Now for the really important part. Where is all this science actually showing up? Is it impacting our lives? The answer is a huge yes. You're probably using it right now and don't even know it. In medicine, this is nothing short of a revolution. Imagine nanoparticles designed to hunt down cancer cells and deliver drugs directly to the tumor, leaving healthy cells completely alone. And you know the mRNA vaccines? They work because of tiny lipid nanoparticles that act like bodyguards, protecting and delivering the genetic code to our cells. That's nanotechnology. Every single time your phone or computer gets faster and more powerful, you have nanotechnology to thank. We're building transistors at the nanoscale, cramming more and more power into smaller and smaller spaces. And those stunningly bright and colorful TV screens, a lot of those use something called quantum dots, tiny nanocrystals that light up with incredibly pure colors. Nanotechnology is also becoming a huge player in the fight for a cleaner planet. We're using nanomaterials to make solar cells way more efficient at soaking up sunlight. And there are even new ideas like blue energy, which uses membranes with tiny nanopores to generate clean electricity just from mixing saltwater and freshwater together. Incredible! And as you can see here, the impact is just everywhere. In manufacturing, it's giving us stronger, lighter materials for cars and planes. In the clothes you wear, it's creating stain-resistant fabrics. It's even being used for water purification. Nanotechnology is quietly and powerfully improving the world all around us. So, if that's what's happening right now, what does the future look like? Well, this is where things start to sound like science fiction, but they're getting closer every day. We are on the verge of things like tiny nanorobots that could perform surgery from inside your veins. We're looking at materials that can literally heal themselves when they crack. And we're on the cusp of an era of quantum nanotechnology that could unlock computing power we can barely even comprehend today. And that really brings us to the final thought. Nanotechnology is so much more than just a new set of tools. It's a fundamental new power for humanity, the power to arrange the very building blocks of our world. And so the biggest question of all is, as we get better and better at mastering the science of the small, what kind of world are we going to choose to build with it?